morning, and nice to meet you all. I'm seeing, quite a few faces, right? My name is Tuhin. I'm already introduced, right? So I'll just, tell a bit of things which is probably you don't know, right? Um, I work as a senior principal data scientist at Red Hat, and the main work that we focus on is how we can actually build and utilize the Gen AI applications to uh, increase the operational efficiency of different business units at Red Hat, right? So that is pretty much we are actually focused on. Today, we are going to talk about how Red Hat is in the path of transforming the whole AI landscape through the core strength that Red Hat has, which is open source. And I'm also going to take you through a few of the reference architectures that we have actually built as part of our day-to-day work at Red Hat, and a simple state-of-art workflow of what exactly happens inside a GenAI application, and how exactly Red Hat's various open source technologies and initiatives are actually powering and fueling that particular initiatives, right? So let's move to the first slide, right? So first we are going to talk a bit about what exactly open source's role and how exactly it is connecting with AI, right? So I believe you already watched the keynote sessions, and there it has been actually talked about in detail, right? So I will not spend much time here. I'll just touch base on so that you have the context for the later content, right? So if you look at the open source, by the name of it is the source is open, right? So you actually know for a particular tool, if it is open source, what exactly is going behind the scene, right? So starting from the code base, what exactly the logic is, and based on the licensing terms, you are free to study, modify, distribute, and utilize them for your business need. So how exactly AI comes into picture? So Red Hat actually is looking forward to transform the AI landscape through the same strategy, right, that we have actually adopted when we worked on the RHEL, that is Red Hat Enterprise Linux, the Openshift, which is a container deployment platform, and then we have Ansible automation platform, right? So all these products that you see, right, the foundation is the open source, right? It is built on open source technologies. And Red Hat is looking forward to do the same thing, right, for the AI, right? That is not something very popular yet, right? And Red Hat is going to disrupt that particular field as well. So last year, actually, the product Red Hat OpenShift AI, right, that was actually unveiled in the Red Hat Summit. This year's summit is just, in a couple of weeks' time is going to happen. And last time, what we showed is 80% of the enterprises, right, that we are actually seeing as of today, right, they will be deploying Gen AI applications in next couple of years, right? So there's going to be a huge demand. Of course, you are seeing all the crunches in terms of the GPUs. It is very difficult to get hold of GPUs, and where do you think the GPUs are getting utilized for, right? So that is where the Gen AI applications are getting powered by. So there's going to be a huge demand, right? And Red Hat is actually just looking forward to catering to, right, through its open source collaboration and the contributions. So what exactly AI needs, right? So we'll talk a bit about step by step how to think about how AI, or in specific, how Gen AI applications actually work, right? So the first thing is you need a hybrid cloud, right? So what exactly is this, right? So if I'm thinking about, let's say, I want to build a simple document question answering system, right? So what happens is the data is in some API through which I can actually get those documents, or it is probably, let's say, make it simple, it is stored in some object store. Let's say S3 data store, it is there, right? So we need to get those data into some infra, right? And then we need to actually run some training of the model or run some batch workloads. So that will require some platform where we could actually run, right? Eventually, once we train the model, we need to save it somewhere, and then probably if you are using some cloud service provider, then where exactly, I mean, the places where the training is happening, not necessarily that is the same place you are going to actually deploy those applications, right? So that could be a separate cloud provider or your private cluster or a kind of, I mean, public network itself, right? So altogether different. So that is where the hybrid cloud comes into picture. So it's the ability to move between clouds depending on where your data is, where your use cases need to be run, and where you want to run your inferences, right? So that is the first thing that you will be needing, right? And if you look at the survey that has been done, right? So 200 unicorns in US, actually, we went through, I mean, the survey. And what we found out is 93% of those companies actually run their workloads in various, I mean, different public cloud providers. And 81%, they use multiple public cloud and one or more private clouds. So we talked about the hybrid cloud, right? So the next thing that we'll be needing, right, is some operating system, right? So where those applications or the platform actually can be hosted, right? I mean, as we are talking about Red Hat, right? So that is where the Linux actually comes into picture, right? So if you look at the total number of public cloud workloads, 90% of them actually runs on Linux, and 96% of the containers, right, also actually runs on Linux. Red Hat Enterprise Linux is actually bridging that gap, right? So with the 24/7 support and upgrading your operating system at your own schedule, right, just adds or boosts this whole initiative there. Now, we talked about the hybrid cloud. Then we talked about the operating system on which the applications would run, right? But before that, we'll be needing some platform, right, on top of that operating system, which will actually host varieties of applications on top of it, right? And that is where the Kubernetes and Openshift comes into picture. So we'll come, to that point, how exactly Openshift looks like, various components, and how the AI is going to tie with it, right? So just wanted to summarize what we have just followed, right? So it is much better to actually follow the next content as well. So if you look at it, we started with open source, right? So you start a project in open source, or you consume some open source tools, right, to build your application. Then you'll be moving to the cloud computing and automation. So for cloud computing, you will go with the you can go with the Openshift, Kubernetes, right, deployment, and Ansible for the automation. And once you do that, right, and that is the where the next leap is going to be, right? Once you are comfortable doing that, then the artificial intelligence and machine learning capabilities that you'll be needing, right, as part of your applications. So how exactly to work on various technologies of AI and machine learning that is there? So before going to the AI, let's talk a bit about how Red Hat OpenShift is structured today, right? So if you look here, the Red Hat OpenShift Kubernetes engine, right? So it consists of the Linux, which is the operating system, which actually is the container host operating system. And it contains the Kubernetes and the various cluster services, right? So it actually includes the networking, the ingress, the storage, monitoring, etc. If you look at these two blocks, they actually can be run in physical machines or virtual machines, the private cloud and the public cloud, as well as edge. On top of the Red Hat OpenShift Kubernetes engine, the Red Hat OpenShift container platform comes in, right? That is called OCP. So what actually it provides is the service mesh, serviceless architecture, the builds, pipeline, the log management, the migration tools, the GitOps, right? So all the various things that you'll be needing, right, to manage your application that is just, I mean, built on top of that as a layer. And then finally, you have the Red Hat OpenShift Platform Plus. That is where the advanced management and security comes into picture. There is the multi-cluster management, then the global registry, cluster security. So all those things actually comes into picture. All this, I mean, layers of the stack that you're seeing, right? So they can be actually hosted on the public clouds, like Red Hat OpenShift service on AWS. Then OpenShift dedicated in the GCP, then the Azure Red Hat OpenShift, and eventually it can be available and used on IBM Cloud as well. So this is where the AI and ML comes into picture. So if you look at the upstream projects, so there are various open source upstream projects like Jupyter, then Kubeflow, Ray, TensorFlow, Scikit-learn, and all those things, right? Then we have a community project, which is the Open Data Hub. So what Open Data Hub does is it actually provides an open source AI platform, right, which actually leverages all those upstream projects, and it actually makes it really easy to use, then build your application, test it, and deploy, right? And that is where Open Data Hub is actually working as a bridge between all the popular AI upstream projects and bundling them together, right, in a consumable format, right, for the machine learning engineers, the application developers, and so on, right? So it actually reduces the time to the production by quite some great extent. And that is where you are seeing that funnel, right? So on the top of the funnel, the various upstream projects, which is actually coming through the Open Data Hub, and that is basically getting leveraged by the Openshift AI, right, to create that unified framework, right, on top of OpenShift, where actually you can run very powerful workloads that you can scale at will, do a lot of monitoring, and figure out what are the pain points or the problems that is there probably in your stack, right? And you can actually quickly fix them. So this is where the Red Hat OpenShift AI comes, and these are the various features, right, that you could actually see it, right? So for any Gen AI application, right? So the way you will start your application development is you need some development environment, right? So you have some data, let's say in S3, so you need to connect it to S3, get the data into some notebook, and you should be able to do some sort of, experimentation, build some POCs, collaborate with various teams, and then finalize that, well, this is a good model, this is a good results that I'm getting. You finally publish some of the metrics like the precision, F1 score, and so on. And then finally, we say that, well, this is a good model to go forward with, right? So from the POC, let's move to the MVP, right? So for the MVP, what you will be needing is you have the model trained in collaborative manner with your teammates, right, inside or outside, and then eventually we'll be thinking about how we can actually deploy that model, right? So if we talk about the GenAI applications, so that will require a lot of GPU compute, right? That is, the acceleration will be needed in terms of the hardware. So it actually provides you just out-of-the-box runtimes. For example, Hugging Face has the runtime called TGI, right? So text generation interface, using which you can actually deploy any Hugging Face models, right? So if you look at the Hugging Face, the repository, it is nothing but a GitHub repository, right? So with large files enabled. And all the models, right, which are actually following the transformer-based architecture, they actually follow the similar folder structure. The file structure has tokenizers in certain format, and the weights are in certain format, right? So it is pretty standardized format on which the Hugging Face models are actually stored, specifically the transformer-based models, and that's why the tool that Hugging Face created, that is the TGI, that can be actually just, used out of the box to load any models, right? That you have actually just using as a pre-trained way, that is, you are not doing any fine tuning on top of it, right? Or even if you do the fine tuning, right? So the way you are going to store it through the transformer libraries, it will be compatible with the structure that TGA actually needs. There is another tool that is there for doing the model deployments, which is called VLLM, right? And that is also a pretty good one. It actually provides out-of-the-box OpenAI compatible APIs, right? So I'm not sure how many of you actually went through or coded in LangChain environment, but if you have done, you will see that most of the examples there are actually OpenAI compatible ways of doing it, right? So if you are developing Gen AI applications, right, or you're deploying models, right, using either TGI or specifically for VLLM, I can say, all these deployments specifically for VLLM, right? So these are OpenAI compatible deployments, right? So you can just, mention your secret key as empty, and you can just seamlessly integrate with any LangChain modules, right? So which is very popular in building the RAG pipeline. And before that, once you take your model to the production, right? So not necessarily that is the model will be staying there forever, right? So you'll be running continuously. You are going to improve that model over time, right? So you're going to feed more data, figure out whether the model is performing better or not, and based on that, you are going to take a call whether the previous model that was actually in the production, whether you want to replace it or if you want to keep it running, right? And that is where it is very important to version the models, right? And that's where the Openshift AI model registry comes into picture. That is the easiest way so if you look at the whole picture, right? So you can connect your data, you can train models in collaborative manner, you can store the model, version the model, and then based on the performance of individual runs, you can actually take the model to production through various runtimes that is available, which is anyway open source, right? So all the components you will be seeing, it is actually built on open source. Now, coming to the next one, right? So this is what actually I wanted to show as a reference architecture for any Gen AI application that you will be thinking of building, right? So if you look at the left side, the data sources you have, for example, these are just a placeholders I have used just to explain, why they are there, right? So you have Redshift, the Snowflake, that is where the structured data are going to reside, data related to your finance, data related to your product information, customers, and all the stuff. In S3 and Google Drive, various information regarding the unstructured data, right? So what about the source pages or the knowledge articles or user guides that actually can reside in this particular data sources, right? So we are just covering that the structure and the structured data, both can be actually utilized in this particular architecture. On the bottom, you're seeing that it is OpenShift AI CPU and GPU compute. The CPU compute is for just hosting the CPU-based applications, and the GPU compute is for actually hosting the actual LLMs, right? The bottom two boxes that you are seeing here, the open source box and the proprietary model, right? So in the open source model, all the models like the Mistral, Mixtral, then all the other Hugging Face models, which is actually publicly available. That is where I have just put the placeholder here. That is where the LLM and the embedding model is for just converting the textual information into the numerical counterpart, right? So we'll come how actually embedding model is actually helping the whole framework in the next slide to explain how exactly it actually works in the larger span of Gen AI applications. Now, coming to the proprietary model, so I've just given some examples like, so IBM has a model called Granite model. So it is also a large language model, very similar to what we have like, Llama or Claude and so on. And the Slate model is the name of the embedding model that IBM has developed, right? So all that information, you will find in the footnote that I have included. So what happens is these two places where the LLMs are deployed using the GPU compute, right? And they are actually exposed as OpenAI compatible APIs, right? So when you actually, I'm pretty sure everybody used ChatGPT once at least. I mean, so far, right? So if you actually type any questions there and you hit enter, the ChatGPT actually starts answering right away, right? So it actually streams the output. So that is somebody is actually typing those answers back to you, right? So you don't. So actually, when the API ends executing is when the last character actually comes right on the screen. So that is the total time it takes to generate the full answer for you, right? But essentially, you are not actually waiting for the full answer to be present to you before actually seeing the answer, right? So somebody is actually in real time, somebody is streaming it, right? So that is the capability, the TGI, the deployment, the model runtime, and VLLM. This is another runtime. So both of them actually provide, right? That is you don't have to actually wait for the last character to be sent to you, and you can just, see the answers just the moment you hit the question, right? So you can see that these two boxes, they can be actually, whether it is open source or it is a proprietary model, right? So they can be just, directly be deployed on Openshift AI GPU compute, right? So without any issues, because Openshift AI comes with those functionalities, the runtimes, where we can just, point to S3 or a Minio bucket where the model is, right? And it will just, pick it up and it will just, deploy. Then what happens is on the right-hand side, there's a VectorDB, Milvus, right? So Milvus is also an open source database. So I'm not saying that Milvus is the place to go. It's just an example that I have provided. There are many other vector databases like, Quadrant, then ChromaDB, right? So all those stuffs are there. Milvus is one of the very popular ones. It actually has intrinsic RBAC system, the role-based access control, which is not there in any of the other vector DBs so far. And also it comes with a very good UI, which is actually built using a 2 framework. And that is the way you can actually manage, maintain the users and the various collections and the records in the vector DB. So the reason vector DB is needed is it is not always possible or I would say feasible also, right? Just to train every pre-trained model which is out there and just fine-tune based on your data, right? So in most of the cases, it is because of the lack of the hardware, the cost, and all those things. It is not actually popular, right? Also not feasible. So in those cases, what you do is you actually create a vector database and you create the embeddings of your input data and put the data inside the vector DB, right? So essentially the whole goal is when some question actually comes to your GenAI application, right? So you first find out what are the similar documents to that question, and you go to the vector DB that, hey, this is the question I've got. Out of the 100 documents that you have already ingested, which are the 3 documents which actually may contain the answer to this particular question, right? And then you get that subset of the documents as a context, and then you go to the LLM and say that, well, this is my question, this is my context, can you give me the answer, right? So that is a very popular way of doing it. So it is called RAG. So the retrieval, you retrieve the embeddings, then augmented, you augment that context to the prompt that you are going to ask the LLM, and generation, and that is where the LLM actually generates the answer. Then you have the Openshift AI model registry. So in case you actually do the training on the same model on various data set over time, then you need to keep track of what are the different versions of the model which is available. And then when all these things are done, then you can actually build various business logics. So for example, in this case, there's a doc QA application, and there's a visual question answering application. What it is actually essentially using is the underlying data, which is there in the Milvus, the LLM, which is actually deployed here. And then you can write a business logic on top of that, and you can expose them as REST endpoints. Then you have the API layer. Using the fast API, you can actually include the authentication and all the stuffs there. And then eventually through the UI, Streamlit or Chainlit or Grad.io, right? So those are the various technologies you can actually use to just expose through a user interface. So this is the last one, and this is exactly what happens inside a model server, right? So when some user actually asks a question, right, what are the different phases it actually goes through? That is what actually is shown here. So in this case, it is a doc QA application. So what is happening is there are various source page information of certain product, let's assume. And that source page, the documents, what essentially we are doing here, we are creating chunks out of it. And then each of the chunks we are passing through an embedding model. So for example, a BG large English version 1 model, any embedding model you can actually look for in Hugging Face. And then what it is doing is the embedding model is transforming those textual data into the vector representation, and it is actually storing in the Milvus vector DB, right? So this is I mean, it starts with the one time, then depending on how the source page is actually modified or updated, right? Or what is the, let's say every week the source pages get refreshed, right? So you run a weekly job, right, to make the embeddings up to date. Then, so this is where one flow ends, A and B, and then this is where the real time flow actually starts, right? So as a user, actually, I come, right? And then from the source page, actually, I want to know, for example, let's say I'm facing some issues for Openshift installation, right? And then I want to know, like, this is the error stack trace I have got. So what is the way I can actually fix this? So I come up with this question. It actually goes to the LangChain framework, right? So it is the acting as the orchestrator. So the first question, first thing it is going to do is it is going to actually append that question to a chat history, right? So assuming that you have done already some interaction in that chat, right? So you think about the chat GPT, right? So you can actually start a new conversation. You can chat with it, and then probably you can ask a follow-up question, right? So what essentially happens is all the questions that you have asked so far and the follow-up question that gets actually attached together, right? And then it actually creates a historical prompt. Then it goes to a LLM, and then you say that, well, this is the error I have got, and the question that, and the answer that you gave is not right, it is not satisfiable, and I want to stress on this particular error stack trace, right? Can you refine your answer again, right? So that is sort of, I mean, a historical prompt that would actually look like. Then the question generator, what it will do is it actually summarize the whole set of questions, right? I mean, you may have asked 10 questions, 15 questions before, and it will summarize all the things into a single question, right? Then that question standalone query is coming back to LangChain again. Then the question is going to hit the embedding model to get the numerical representation of that question. That numerical representation goes to the Milvus, and it really asks Milvus that this is the question that I'm actually looking for. Can you give me top 2 or top 3 documents which can actually answer this question? Then it actually sends in step 8 the similar schemas, and that is where the LangChain has 2 things, right? So one is the final question, and the other is the context that is got from Milvus. So the query prompt, the standalone query and the context, that actually goes, and the question prompt is going through another LLM, that this is the context, this is the question, can you give me the answer? Then the answer actually goes to the user. If the user likes it, it just ends there, right? User is happy. If not, then user is going to come with some thumbs up or thumbs down, right? Some feedback. And that is where there is a feedback prompt. If it is thumbs down, that is, this is the question that has been asked. This is the context which was given, and this is not satisfactory. Can you re-look at your answer again, right? And that is where the feedback loop actually goes back to the model, and then the answer is actually modified and fixed, right? And by the time user gets the answer, and it just ends. So this is a reference workflow that looks like, and so we just, I mean, ended. I'm not sure if we just overflown a bit, but any questions I can answer now? Yeah, please. Thank you so much.